So that should be recording. Yeah, there we go. Okay, thank you very much for your time, Dr. Harrison. It's great that you're able to join us. So I just wonder if you could give us a quick overview of the work that you've been doing with the COG UK consortium during the pandemic.
Sure. Thanks for having me. So since basically in early March, a group of people, of academics, public health scientists from across the UK came together and realised that the UK's kind of expertise and existing infrastructure could be turned around to deliver large-scale genomics for the UK. On coronavirus. So very, very quickly, we put together a funding bid that went to the UK government, to UKRI, and we were awarded £20 million to build what was initially really more of a research network. And that's based across 17 sites across the UK, 2 in Scotland, 1 in Northern Ireland, 1 in Wales, and then the rest across England. And we also have a very large sequencing hub at the Wellcome Sanger Institute, which is associated with large-scale genomics and has turned a lot of their pipelines around. But we have a really kind of a spoke and a hub network. So the spokes are all across the site, and the Sanger acts as the main hub. We've also built a computational infrastructure for handling the data. So all our samples and data flow into a single facility, which is the CLIME server, which is based in Birmingham and Cardiff, and existed before the pandemic, but has now been expanded to deal with particularly with the COVID genomics work. We receive samples from both NHS diagnostic laboratories, but also the large Lighthouse labs, and we have a really huge logistics effort underway daily, moving these samples, literally hundreds of thousands of samples moving around the network into our sequencing sites to be sequenced. Mm-hmm. At the moment, we're delivering about 10,000 genomes a week, but that's increasing.
And you're taking in samples from patients or people who've tested positive, and you're then sequencing the viral genome from that. Is that correct?
That's correct. Yeah. So we can take samples from anybody who's a positive case, but we do that with quite a focused sampling strategy. So we try to ensure that we collect samples from across the UK equally, but also, as we'll probably come on to later in terms of our interest in linking with health data, we're also very focused on collecting samples from patients in other kind of studies, but also from the most severely ill, imports, potentially coming now, any cases of vaccine failure. So as well as kind of conducting surveillance across the country, which is really important for just monitoring viral evolution, we're also targeting towards the most severely ill patients.
And the importance of understanding viral evolution, just wonder if you could say a bit more about that.
Yeah, so I think this is best exemplified by obviously what happened just before Christmas here in the UK, when increasing cases in the southwest of England was associated with a novel lineage of of SARS-CoV-2, which is now called B.1.1.7. This lineage has now basically taken over the viral population in the UK, and viral genomics has tracked this happening. We were able to detect it because we were sequencing the virus. We were doing this surveillance. If we weren't conducting this routine surveillance, we would have never identified this virus with these particular mutations.
Sure.
And this is important because we've found that some of these mutations are concerning because they're in parts of the virus that we know are interacting with the immune system. But they're also, our data has enabled mathematical modelers to basically ascertain that this form of the virus is more transmissible. So that means that governments around the world have been able to prepare, for the presence of this virus.
Absolutely. And what have been some of the challenges you've encountered both in capturing and making this data available and sharing it?
Yeah, so it's obviously been a huge challenge, and a lot of the problems that we've faced behind the scenes have been around data. So obviously we have to, on a day-to-day basis for our logistics and for our sequencing, we have to have a huge amount of data moving around. Just about, we receive massive batches of samples. We need to know they're in plates. Which one is the positive sample? We just need information like that. We also have to, and we have to have that quickly, because we need to obviously, as soon as a sample arrives, we need to have that data. So that's been a major problem, is getting those kind of data flows going. We also have to get data regarding patient information and move that around the system. And we've had to build agreements about which kind of data that we can hold within our central systems, but which kind of data has to remain within things like NHS Digital, more specialised data handlers for patient level data. We also share our data freely. So all our data goes into the public domain. We've been doing this since day one. Initially, we put it on our website, but it now goes into a number of databases, including the one called GISAID, which most people might be familiar with. That had, in the initial stages of putting that together, that caused problems. We had to get agreement across all four nations of the UK from their public health agencies. And things like postcode data, for example, in the UK can't be released because a simple postcode data from somebody in one of the Scottish Islands will identify an individual case. So
yeah, and that's even at the outer
data.
postcode level, isn't it? Sort of the
That's
BA1
correct.
or the CB1 or the YO1.
Exactly. So we can't release that kind of data. So we only release the UK nation, all the sequencing data, and the date of sampling, which is really important for a lot of the analytical methods in viral genomics. So that's enabled us to share data quickly and rapidly. But I'm also aware that in a number of other countries, people have got stuck in these questions around data sharing due to these things about releasing patient identifiable information. So we've gone for a simple approach. It's better to have the data out there than it is to have, basically limited data with rich patient level records.
Sure. And we talked a bit before about how openness can come at a bit of a cost to the organizations publishing it, both in monetary terms and also in kind of opportunities. I wonder if you could say a bit more about that.
Yeah, so I mean, from our perspective, we make all our data freely available, and if in a level playing field, everybody would suck up that data, make use of it, but then obviously would get in contact with various people when it comes to things like publications. But there's been a number of situations where people have sucked up all that data, analysed it, and then tried to publish it really without getting in contact with the data generators. And this is obviously it's a balance, but I think we think that it's more important to share data, and we just encourage fair use of that data. Particularly when, in many cases, people who've generated that data are conducting quite detailed analyses. So somebody may publish a study that's quite superficial, whereas actually the people who've generated that data may well be experimentally validating that, and these kind of things take time.
Yeah,
but I think this is something that's it's really critical that we share the data, so we practice what we preach, and we make sure it's freely available.
Yeah. Obviously, the UK has incurred a bit of a hit by being so open about the emergence of the new variant. But if other nations aren't sharing data at a similar level, what harms can you see arising from, not sharing to the same level?
So if you take the example of the lineage that arose, this B1117, so the earliest cases of this are detected in the UK. We've got, I think, cases stretching back to, I think there was one case in September. When we look back in our data. So, it looks like that potentially emerged in the UK, but because around the world, not everybody's sequencing at the same levels we are in the UK, we can't for sure say that actually wasn't initially imported into the southwest of England, which obviously has, a lot of ports like Dover there. It may well have been imported into England and then spread, and then obviously spread globally. But again, it may well have equally have emerged, within the UK, and we haven't found kind of patient zero.
Yeah,
but I think this makes the point. Sorry,
I was going to say, without the capture and availability of data kind of globally, it's impossible to know either way, really, isn't it?
Exactly, and it has, of course. I think that in many ways, actually, it will have. Although that came at a cost, that obviously this came out of the UK and has spread, I think it's probably made governments around the world that don't have genomics programs. I would assume that a lot of them are now starting to prioritise them. So although it may have had a negative impact in terms of it being called the UK lineage or the British strain, etc., I think it will have had a positive impact globally, because people will realise that genomics is really important and data sharing is really important, so that we can all understand how things are moving and potentially adapt border controls, quarantine procedures to respond to that.
Yeah. And as you alluded right at the beginning, there's clearly a lot of potential in linking viral sequences to more data about the patient. What opportunities and barriers do you see in this area?
So this is something that I'm particularly involved in, and I think that as a consortium, from day one, we were very keen to do this. We have quite strong links with Health Data Research UK. I mean, they fund my salary. We've tried to ensure that we link with data. So we've been working with our colleagues in the genomic study, which is the human genetic susceptibility study that's already found a number of host genetic variants. So we work to ensure we have linkage with them. We're also working with organisations like ONS, SAIL database in Wales, other trusted research environments across the UK, and we're now trying to get our data as quickly as possible into those environments so that they can be linked with these rich, electronic health data sets, really, so we can start tackling questions about, does a viral variant, is it associated with more severe disease, or certainly to the questions that individuals can use viral genetics to, as a potential, if it's a confounder and they want to remove it from their analyses. So we're very keen to do that. It's quite a complex process, obviously, that requires lots of information governance, sign off, and ethics, and the ability to move the data between a safe environment within our existing legal framework. So things like moving NHS numbers around requires some legal framework. But we're getting there, and hopefully, certainly within the next month, there will be quite a widespread linkage. We've already got linkage of 20,000 cases in the ISARIC 4C database, which is a rich database of patients who've had severe disease. So I think it's moving in the right direction, and it's something that we really care about.
Yeah, but in most cases, you've had to take your data and put it into those research environments rather than being able to get and bring it into yours.
Yeah, that's the best way. So our computational systems are, we have secure computational systems, but we hold a kind of a minimal data set that's more useful to your viral genetics research. Whereas we've made the decision that for linking with complex electronic health record data, that it's much easier for us to basically pull out the mutations that are present in the virus, link those to an identifier that then allows a linkage in a trusted research environment.
Yeah.
And those trusted research environments are set up for doing this kind of research. So rather than reinvent the wheel.
And we talked a lot about how data sharing during COVID has been enabled specifically for COVID by legal instruments. Those don't obviously exist for other conditions than some of these other data sets. So I guess in some respects that means the process is a lot slower and therefore much harder to do the kind of real-time activity you talked about being able to do for the viral genetics.
So yeah, we're also looking at using the data in the trusted research environments to port back into our because we're able to hold for all 4 nations, so we can hold UK-wide data. So one of the things that we're thinking about doing is, for example, can we capture mortality data, at 28-day mortality data across the UK in these databases, and then feed that back into our central system, where then that can be analysed with the whole data set. But we're just trying to be as flexible as possible, and obviously we're very keen to maintain a UK-wide data set where possible. But in some cases, the limit, as you outlined, that there are limitations to that, and we just have to work within the constraints.
Yeah. So finally, just what positives or learning can we take from COVID sharing specifically that could be applied to other kind of non-infectious diseases like diabetes or cancers?
Well, I mean, from my perspective, being involved in infectious disease research, and my focus is for the past sort of 4 to 5 years has been on linking electronic health record data with pathogen genomics and host genomics. I think that we've obviously learned a lot during COVID about that there are barriers there that in many ways are artificial barriers that I'm hoping will have come down. I think there's going to be, when we get back to some kind of normality, there's obviously going to be lots of people thinking, we did this fantastic research during COVID, we could link data set X with data set Y easily, whereas that had taken us, 18 months of legal wrangling. So I'm hoping that, I don't want to call it kind of red tape, but I think that there's going to be, people are going to realize the possibilities, what that will enable researchers in cardiovascular disease and, in cancer, and the infectious diseases to do. So I'm confident that I think we'll come out of this with a much clearer understanding of the power of, linking electronic health record data nationally, and and putting that to good use, really, rather than data sitting in silos.
Sure. I mean, obviously there are always risks in sharing information, but I think we've been able to kind of boost the benefits bit side so people can see how those balance.
I think I think we've overcome. I would presume that there have always been objections, and rightly. And we,
Mm-hmm.
I think one of the things we'll probably have to do, as soon as this is kind of all over, is sit down and say, okay, so we've got this new playing field, but what are the rules?
Yeah.
How's this going to work now? We obviously want data sharing to continue, but we've obviously got to put in place, robust controls, ethical frameworks, etc. But without returning to a point where data gets siloed in different locations, and it's just simply not worth the effort linking two data sets, which is in many cases just a matter of sharing a couple of CSV files with identifiers, and it allows you to link those two data sets.
Yeah, absolutely. All right, well, thank you so much for your time. That's been a really helpful setting of the scene to show both the art of the possible, the controls and challenges, but also the opportunities. So thank you very much.
Thanks for having me.
You're welcome.